Okay, class, this is number 37 on page 156. Okay, I like this problem a lot. I think this happens a lot in real life, so I want you to hopefully try and figure this out. Okay, so we're gonna have two events happening. Event A, the person has the disease. They are infected. So that they either have it or they don't. So A is the status of the person. Are they infected or not? B, the person tests positive. Okay, so B is the second event. They're going to either test positive or negative. B is the person tests positive. So reading through the problem, it says 1 out of every 200 people have this certain virus or disease. Okay, so that's just what they gave us. So probability A, that the person is infected, is 1 out of 200. So what's the probability they're not infected? Okay, well this would be 199 out of 200. Okay, we're going to need this for this problem. The second thing it says is a test used to detect the virus in a person is positive 80% of the time when the person has the virus. So, given they have the virus, do they test positive? This, according to this test, that's only going to happen 80% of the time. When a person actually has the virus, they're going to test positive 80% of the time. So, what if they have the virus, right, but they don't test positive? Well, that would be the complement of this one. So 0.2, excuse me. Now, we don't need this answer over here for part A, but we're going to need it for part B. So I'm just going to go ahead and put it in there now. Okay, second thing, they test positive, but they don't have the virus. This is called a false positive. The tester made a mistake, or the test that they're using made a mistake. Now, it doesn't happen very often. It only happens 5% of the time, but it does happen in this problem. So, person tests positive, and they don't have the virus. So that would be this part. They don't have the virus, but they still test positive. 5% of the time. So looking over here, they don't have the virus, and they don't test positive. That's going to happen 95%. And you'd expect that. That if somebody doesn't have the virus, well, hopefully it doesn't show up that they do. So it's not a bad test, right? We still have a 5% error here, but it's not an awful test. So the first part A, you're just going to fill in the numbers for this formula. I think everyone at this point should know how to do that after you've done 33, 34, 35, and 36. Okay, but now for part B, we need the opposite of this. So we need the probability of not A given not B. So what's the probability that we don't test positive and we don't have the disease? Okay, so we haven't done that yet. We figured out what's the probability we have the disease if we test positive. Now, what's the probability we don't have the disease if it doesn't test positive? Now, think about this. You go in to take a test for, I don't know, hepatitis or something. Okay, so this one up here is figuring out if you actually have the disease and you test positive. And that turned out to be a really low percentage. If you test positive in this particular case, you're only going to have the disease 7% of the time. So a really, really, really small number. Okay, but what's this? This is that you don't test or you don't test positive and you don't have the disease. So let's figure out what this is. So using the pattern up here, it's probability of A given B. So on top, it's probability of A times the probability of B given A. So here we're looking for a probability of not A given not B. So we're going to put probability of not A here times the probability of not B given not A. Okay? Divided by, again, if you look up here, this first part is repeated on the left down here. So I'm just going to repeat that here. Probability of not B given not A. And then what do we do over here? Well, over here we have the probability of not A. Here we have the probability of not A here. So this must be probability that A happens. And second part would then be the probability that B doesn't happen, given that A happens. Okay? And I'll try and explain this a little better in class. The bottom line is, we want to know, all the times we don't test positive, right? And just like up here, we want to know all the times we tested positive, okay? Because that'll factor into the probability that we actually have the disease when we test positive. We want to know all the times we don't test positive, okay? And that's going to happen sometimes when we have the disease and sometimes when we don't. Okay? So I'll let you put in the numbers. That's why we did all this work up here. We already have all these numbers. We have probability of not A. We needed it for the last problem. We needed it right here anyways. We have the probability of not B given not A. It's 0.95, so that's what's going to go right here. Okay, so I'll actually bring it up here now that you have the formula written down. And you can grab these numbers and you should be able to substitute it in. Pause the video here, but when you're done, you should get 0.999 as an answer.